Good morning, afternoon, evening. When are you watching these? Anyway, all right, our last skill for this unit is inverse trig functions. What are they? Well, you've actually already used them when solving triangles, and you've used them on your calculator, but we are not using our calculators anymore, ladies and gentlemen. There is no need. What does it look like? Well, let's say, hypothetically, that I had, oh fudge, I had a pen. There we go. I had sine of x is equal to rad 2 over 2. Well, I can't take the sine of x. I don't know what x is. So in order for us to solve, we apply the inverse. So inverse sine of the side ratio, and that will ultimately give us the angle measure, be it in degrees or radians. Okay, throw back to our inverse unit. Yeah, we have to have that -1 exponent. Okay, so we read this as the sine inverse sine of rad 2 over 2. And some of us may already know that to have a reference angle of 45 degrees. Hopefully the majority of us do at this point. Sorry, there's a hair on my screen. Okay, come back. So keep in mind, you can also, and you will see it written as, oh fudge, you will see it written as arc sine. Okay, arc sine is exactly the same thing. So arc sine of rad 2 over 2 will give us the same answer because it also means inverse. But some of you may be thinking, oh, arc, radians. Yes, arc deals with the rotation and the movement around the perimeter of the circle, which is what the radian comes back. So if it's arc, it's the rotation, we'll say, of the arc. Okay, either one is your inverse. So for this one, let's go to our unit circle. If I were to ask you the inverse sine of rad 2 over 2. Okay, so we're thinking ASTC that you can see on the left-hand side, and it's the first and the second quadrant for a positive value of sine. Okay, so if I take the inverse sine of rad 2 over 2, I'm going to say, oh yeah, it's 45 degrees. But I'm also going to say that it's 135. And then I'm also going to say that it's 405 because I know that I can add 360 degrees and get a coterminal angle with that same value. It shares that same terminal side. I could also subtract 360 degrees, and I could keep going and going and going, and those would all have the measurements that I needed of sine value being rad 2 over 2. Well, the problem is I don't want a myriad of answers. I mean, I'm sure you guys can go on forever, but you don't want to either. So I want to make sure that we're all finding the same value. And that's the problem that mathematicians came across back in the day. Now, it also has a lot to do with the graphing portion that we'll see next unit. So for now, I just want you to get comfortable with memorizing the restrictions that fall on each of the trig functions. Okay, so if we're dealing with inverse sine of some side ratio, okay, and here we have ASTC. Well, we want to make sure that we are covering both the positive and the negative values for sine just once. So I'm not going to go from 0 to 180. I'm not going to look at my first two quadrants because sine's positive in the first and the second quadrant. What we're going to do is we're going to restrict the sine function to be from, it's not 0 to 90 and then 270 to 360. There's that very large gap. We need it to flow. We're going to say that it exists from negative pi over 2 to positive pi over 2, or negative 90 to positive 90. Okay, so we start from the bottom and go all the way to the top. Okay, so that will cover both the positive and the negative sine values. So sine is restricted from negative pi over 2 to positive pi over 2. Our cosine inverse, come on, buddy, there we go. Our cosine inverse, well, it doesn't have the same quadrants as sine. In other words, it can actually have all of its positive and negative values within the first and second quadrant. So cosine is going to be restricted from 0 to pi, or 0 to 180. And last but certainly not least, we have tangent. Okay, so our inverse tangent is going to be restricted. Yeah, some of us might think we could go first and second quadrant because realistically it has both the positive and the negative values, right? But again, going back to the graphically, it'll make more sense as to why it is restricted exactly the same as sine. And for now, we'll put the less than or equal to, but know that tangent happens to be undefined at -90 and at 90. So when we get to graphing, we are not going to have that equal to on the restriction for tangent. And actually, to make it less confusing, do me a favor and erase all the variables. I know, you just wrote them. You'll forgive me. I think for right now, we'll just leave it as inverse sine, inverse cosine, inverse tangent, so that we can just focus on memorizing the restrictions on the inverses. Okay? Excelente. So let's rewrite. Yeah, if I'm asking you to write something in inverse form, let's say I have the sine of y is equal to x, and I need to take the inverse. Well, the input and the output switch. So as it's written right now, y is the input. So if I'm going to take the inverse, I'm going to apply the inverse to the output of the original. In other words, the ratio of the sides. You could also write arc sine of x is equal to y. You don't necessarily need the parentheses. I like it to distinguish what I'm taking the inverse of. Okay, but personal preference. For b, we're going to take the inverse sine of the side ratio or the original output, and it equals the degree measurement. Okay, and then for c, same thing. So the inverse tangent of -4/3 is equal to x, or you can say the arctan of -4/3 is equal to x. And that's really, really ugly. So let me fix that. There we go. A little bit better. Okay, so go ahead and pause the video for a hot second and try this. And now you're back. So it should say the inverse sine of x is equal to theta, or you're fancy and you did the arc sine of x is equal to theta. All right. Okay, so just writing it, you take the inverse of the side ratios always, and it equals the rotation, be it degree or radian. And my throat's dry. Okay, so example number 2, please, please, please remember your restrictions. This is where it matters, okay? So if we take the inverse cosine of 1/2 and we're looking for x. Okay, so cosine is restricted from 0 to 180, or 0 to pi. Okay, so I need a positive cosine value, which is not going to exist in the second quadrant. We are now in the first quadrant. Cosine of 1/2, we know that, hopefully at this point, to be the x-coordinate of our 60-degree reference angle. So we're going to say that x is equal to 60, or you can say pi over 3. Either one is acceptable because it didn't state in the directions. Oh, I'm going to sneeze. I'm going to pause. Back because nobody needs to hear me sneeze. Okay, the reason that I had to write this one in inverse form is because it was written in the regular cosine of x equals 1/2. Well, what is x? I don't know. So I'm going to take the inverse of the side ratios. Okay, for b, it's given to us already in inverse form. So I need the inverse sine of 1 over rad 2, which we know is the same as the inverse sine of rad 2 over 2 once we rationalize. Okay, so inverse sine goes from -pi/2 to pi/2. Here it is positive, so I'm not going to deal with that fourth quadrant. I'm only going to deal with the first. And rad 2 over 2 is the y coordinate, because it's sine, so y coordinate on our rotation, yeah, of a 45-degree angle, or pi over 4 in radian measure. Excellent. Okay, arctan 0 equals x. So that is the same if we were thinking inverse tangent of 0. Okay, tangent has the same restrictions as sine, from -pi/2 to +pi/2. So if I were to draw it, there we go. So tangent of 0, well, inverse tangent. I get so lazy. Whew, sorry guys. Inverse tangent of 0, that's sine over cosine. So where does tangent have a value of 0? Very good, at 0. So we're going to say that x is 0 degrees or 0 pi. Sweet. Okay, do me a favor, try these. Pause the video. I'm going to pause the video. Okay, hopefully you paused. I paused, and then I did this for us. So inverse cosine, yeah, we had to rewrite in the inverse form for both a and b because it was not given to us as such, and we needed to solve for the original input. So the inverse caused us to do so. Cosine's restricted from 0 to 180 or 0 to pi. Where is cosine 1? Cosine of 0 degrees or 0 radians is a value of 1. As for tangent, inverse tangent of 1, well, right away I'm thinking 45-degree reference angle, because if it's sine over cosine, 45 degrees is the only sine and cosine values that are exactly the same. Pardon me. So it's restricted from negative pi over 2 to pi over 2. And then we know it's positive, so we're in that first quadrant. All right. Yes, degrees or radians, unless the directions state either one is acceptable. And you don't have to write out the quadrants, like I have every time. I just want to be as thorough as possible for you. If you need to, do it. Nothing says that you shouldn't. All right. So last but not least, we're going to be asked to find some values that are a little bit different. So right off the bat, inverse sine of 3 over 13. Right, so those are not my special triangles. That is okay. We can still figure out what we need to. Okay, so we know that sine is restricted in the first and the second quadrants. Okay, so I'm going to draw first and fourth. What? Yes. Okay, and since this is positive, we are going to be in the first quadrant. We aren't going to be in the fourth. Okay, if it said negative 3 over 13, we would be existing between 0 and negative pi over 2. Okay, so then I'm going to draw a triangle as if I existed in the first quadrant. Yes, notice my reference angle is at the origin. As for sine is the opposite over the hypotenuse. Okay, so then I need to figure out, well, what the heck is that x value, right? We drew a right triangle in the first quadrant. Use Pythagorean theorem. So x squared plus 3 squared is equal to 13 squared. X squared plus 9 is equal to 169. X squared is equal to 160. So x is the square root of 160. We don't do plus and minus because it is distance. Good. So we don't want to deal with the negative. We can't travel negative distance. And we have to make sure that we simplify. This could be 16 times 10, so that means it is 4 rad 10. If you need to write on your notes, always, always, always simplify. Okay, it's so important. So how does this help us? Well, we don't know what theta is, and we're not using our calculators because it doesn't matter. What it matters is that we were able to find the quadrant in which theta was existing and where it lied. Okay, so since we knew that it was inverse sine of a positive value, theta is in our first quadrant. Okay, so then we drew our triangle as if it existed in the first quadrant, wrote the sides of the triangle we knew, which was the opposite leg and the hypotenuse because it's inverse of sine, and then we used the Pythagorean theorem to find the missing leg. We could do this because the triangle that we drew was a right triangle. All right, so when it's a composition and it's a triangle that's not a special right triangle, you have to look solely at what's on the inside. Draw the triangle in the appropriate quadrant based off the restrictions. Then, once you have the triangle that theta lies within, then you can do the outside trig function, which in this case is tan. It is opposite over adjacent. We're going to rationalize. So we get 3 rad 10 all over 40. And that would be our final answer. Woo woo. Sweet. Okay, so for this one, inverse of a cosine inverse. That's fancy. Well, cosine here is positive. Okay, so I think I have black. Okay, so if we are with our quadrants and we know that cosine is restricted from 0 to pi and cosine is positive, that means that we are in the first quadrant. And this is a special right triangle, which is super nice. It's our 45, 45, 90 because it's rad 2 over 2. So we're going to say cosine of 45 degrees because this inverse cosine of rad 2 over 2 is a 45-degree angle, or you can say cosine of pi over 4, and both of them are going to give you the same answer of rad 2 over 2. Wait, whoa. So we get the same answer we started with? Yes, you did, because if I have cosine of its inverse, more often than not, they will cancel out. Now, it depends on if the side ratio is negative, depending on the restriction, so it's good to always go through that process. But think about if I have the square root of x squared, what happens? Yeah, they undo each other and you're left with what's inside. So it has the same idea because they're inverses of each other, but due to the restrictions that we have on inverse sine, inverse cosine, inverse tangent, you really need to go through the whole process just to make sure that it works out the way that you think it's gonna. Okay, try not to cut corners on that one. Okay, so I want to find the exact value for each. These are your try these, but I'm gonna do them with you guys, just so we have that extra practice. Arc cos is 1/2. Okay, so again, I'm drawing my quadrants because I want to. It's restricted from 0 to pi because it is arc cosine of 1/2. It is positive, so we are in the first quadrant. The x coordinate is 1/2, which is our cosine, which means that this is a 60-degree reference angle. Okay, so we're finding the inside. So then we get the sine of pi over 3, or the sine of 60 degrees, which we know to be rad 3 over 2. Beautiful. All right, for B, again, it's cosine, so I'm not going to draw the quadrants again. We can just refer back to A because it's also positive. Good. I wondered how many of you would catch that. It's not an inverse. Be careful, you guys. Cosine of pi over 3. So we're going to take the inverse sine. The cosine of pi over 3 is 1/2. Okay, cosine of pi over 3 is 1/2. So now I need to figure out the sine inverse of 1/2. We know that it's from negative pi over 2 to pi over 2, so we are in that first quadrant. And it is the y coordinate. So then our inverse sine of 1/2, oopsies, sorry guys, is going to be either pi over 6 or 30 degrees. And I'm going to throw an additional one in there for you. What if I just wanted to find the inverse sine of negative 1/2? No composition, right? Let's just straight out inverse sine of negative 1/2. Okay, so we're in our restricted areas, so negative pi over 2 to pi over 2. We're not up here anymore. We are now down here. And we know that it normally has a 30-degree reference angle. But we're not going to say, even though we're in the fourth quadrant, this is not 330 degrees. No, because our restriction is from negative pi over 2 to pi over 2. So I'm either going to travel up from the x-axis or down, and in this case I'm traveling down. So I know that it has a 30-degree reference angle, but I'm traveling in a negative rotation, so I would put negative 30 degrees or negative pi over 6. Okay, so be careful with that negative or inverse sine and inverse tangent. All right, rock on.